Hello and welcome to this workshop called Let's Build a Python Web Scraping Project from Scratch. My name is Akash and I am the CEO and co-founder of Jovian. So as the title says, today we will be building a web scraping project completely from scratch. We will write all the code from scratch. I have done no preparation here. I've just decided a project topic that I'm going to work on today. So with that, let's get started. Now, on this page, on the YouTube video page, you will be able to ask questions live during the chat. And if you're watching a recording, you can ask a question in the comments and we will reply to them as well. We will also take some questions live every 30 or 45 minutes. So do keep asking questions in YouTube. The video will be available afterwards on this very same page. And the code for this workshop will be available here in the resources section in the description of the video. Now, the first thing that you want to do is go and open the first link in the workshop, Web Scraping Project Guide. This is where we have a bunch of instructions on how to build a web scraping project. So let's go over the steps of building a project for a couple of minutes, and then we will think of an idea and jump into some coding. Some of you may probably already know, but in case you don't, I'll just start with a brief introduction of web scraping. Web scraping is the process of extracting and parsing data from websites in an automated fashion using a computer program. So you have some HTML website like this website you're looking at, or maybe YouTube, or we look at a few examples, and then you write some code to fetch information out of this website. Maybe you want to do some data analysis. Maybe you want to use that information to build some project. And it's a great way to create data sets for research and learning. Okay, so today we are going to look at the steps involved in building a web scraping project from scratch. It's a great project to have in your portfolio. And it's a great skill to have. It also enables you to practice your Python programming skills, and it's just a lot of fun to do. So do try this out. Now you don't have to follow along right now, because then it may become difficult for you to listen to what we are doing or watch what we're doing. But you can use this video as a reference, and you can use this link as a reference as well for working on your web scraping project. So here, here's what we're going to do. It's a 5-step process. The first step is to pick a website and describe our objective, figure out what we want to do exactly. So we will browse through some different sites and we will pick one to scrape. Then there are some project ideas here. So if you scroll down, a whole bunch of project ideas that we've given here, you can check that section out for inspiration. Next, once we've picked a site, we want to identify the information that we want to capture from the site. And what we really want to do is we want to think of what the end for us looks like. So at the end of a web scraping project, you end up with what is called a CSV file, which is the data that you've scraped from a project or from a site stored into a plain text file. So we'll decide what format the output should look like, and then we'll kind of work backwards from there, so to speak. And finally, we will just summarize our project idea and outline the strategy that we will follow. And this is basically the strategy that we'll follow. And we'll do that in a Jupyter notebook. And a Jupyter notebook, if you don't know, is a great way to write Python code in your browser and also document it and see the outputs of Python code. And we will be using a Jupyter notebook, so you'll see that in a moment. The next thing we'll do is to use the requests library to download web pages from the site that we've picked. We will learn about the request library, and we'll see how to get the right information or the right URLs to download by looking at a website's HTML source code. We will also download and save web pages locally. So we'll find some URLs, download them using the request library, and then we'll create a function to automating downloading for different queries. So we don't want to write code many times. If you want to scrape hundreds of pages, we want to write one function, and then we want to run that function on the hundreds of pages. Then we will be using beautifulsoup, the library, to extract and parse information. So once a web page is downloaded, we will parse it using beautifulsoup. We will use the right properties and methods to extract the required information from the web page. from the HTML of the web page, and then we will create some functions to extract information from each page into a list. And once again, just as we did with downloading pages, we can run that function on dozens or hundreds of pages to extract information from them. And finally, we will create a CSV file with the extracted information. So we take the information that we have parsed out of a web page using beautifulsoup, and we will convert them into lists and dictionaries, and then we will write that information into a CSV file. Then we'll verify the information in the CSV file by reading it back using the pandas library. And finally, we'll also talk a little bit about how to document your Jupyter notebook. Although of course it takes a long time to add proper documentation, but we will touch on it briefly. And then we'll also see how to publish a Jupyter notebook online. Now you can publish to Jovian, you can publish to GitHub, there are many places. But the important thing is any project that you build, you should put it up online. And putting it up online does not mean simply taking the code and chucking it in a GitHub repository. It means adding proper explanations, adding proper headings, adding proper documentation, adding proper instructions on how somebody can reproduce your work. And that then makes it a really good project to have on your portfolio. So if you're interested in data science, if you're interested in pursuing a career in data science, definitely build a web scraping project by following what we are going to do today. Okay. Now we also have a tutorial on web scraping that you can check out later. This is the second link that is mentioned, and this tutorial is it's an introduction to web scraping and REST APIs, and it is a part of the bootcamp, of the Zero to Data Analyst bootcamp. The tutorial is free for you to access, but if you want to attend a lecture where we go through this tutorial, then you can join the bootcamp as well. Okay, so with that, let's get started. The first thing we need is a project idea. Now there are many project ideas here, and I'll let you go through them. Here are some examples. We can create a table of the filmography of some actors or directors, and we can use data from Wikipedia to do that. Or we can create the discography of an artist, which is the list of albums they've released and information like the title, release date, etc. We can create a data set of movies. So we can use a TMDB database, and there are a bunch more here. Okay. I have an idea in mind. So I'm going to use the site github.com, and I'm going to scrape some information from GitHub. Now on GitHub, you have this explore option, and I find this topic section of GitHub quite interesting. So I just want to find out what are the different trending repositories in the different topics on GitHub. So here you can see that on the topics page, this is github.com/topics, and I'll just post that in the chat too. On the topics page on GitHub, you can see that there are some popular topics listed here. Gulp seems to be a popular topic. OpenGL seems to be a popular topic, and Node.js seems to be a popular topic. Okay. And then there is this section called all featured topics. So now on this all featured topics, you can see we have 3D as a topic. And if you click on 3D, let's open that in a new tab. In the 3D topic, it appears that there are 4,077 public repositories. And you can see here 3.js is a public repository on the topic. So this is a GitHub project, 3.js. And you can see in 3.js, one of the topics or one of the tags mentioned is 3D. And it so happens that this repository or this project 3.js, which has a lot of stars, it has about 70,000 stars on GitHub, is the most popular repository in the topic 3D. And then there's another libgdx. So this has 18,000 stars. Okay. Then you have babylon.js. This has about 14,000 stars. Then you have React 3 Fiber. So this has a few more. Then you have A-Frame, and this has a few more, and so on. So for the topic 3D, there are, I don't want to get all 4,000, but let's maybe try and get the top 20 repositories in each topic, right? So for the topic 3D, from this page, we can get the top 20 repositories. Now, if you were doing this by hand, this is how you would do it. You would say like if I do sheets.new, yeah, if I open sheets.new, so you would say here that let's call this top repositories by topic, and then you would start making a list. Okay, now the first topic I want to do is 3D. So I'm simply going to rename this sheet and call it 3D. And in the topic 3D, I want the, let me call that repo for repository, repo name. I want the owner name or just the username. Let's just call that username. I would like to have maybe the number of stars. Let's just call that stars. And then I would like to have the repository URL. So let's call that repo URL. Okay, this is some information that you might want to capture for each topic if you're preparing a data set of top repositories by topic on GitHub. Now on 3D here, it seems like 3.js is the most common one and it belongs to this person, Mr. Doob. So I could just put in 3.js and I could put in here Mr. Doob and I could put in here, what's that? 69.7K. So 69700, I think, sorry, 700, yeah, 69,700. And then I might grab the repository URL, which is this. So copy link address and I might put it here. Okay. Now, why are we doing this exercise? I often see that a lot of people tend to jump to coding directly, but before you start coding for a project and then feel lost somewhere in between, it's always a good idea to just figure out what the final output should look like. And also always a good idea to just do this by hand. So that you understand what you really need to do. Let's do maybe one more and then hopefully you'll get the idea. So here's one. This project is called libgdx. So this is again in the topic 3D. This is the second best project. So we have libgdx, and then we have libgdx. And the number of stars, so both the username and the repository name are the same. The number of stars is 18,300, so 18300, 18,300. And the repository URL, let's grab that. That is this, okay? And then we keep going. You can add repository 4, number 3, 4, 5, 6, and so on. And that's for the topic 3D. And then you can create another topic. Let's see what the second topic is. So the second topic looks like it's Ajax. So let's just open that up. The topic is Ajax, and in Ajax you have a whole bunch of repositories here. So I would call this Ajax, and then I might just put in the same information here, which is all that, and put this here. And then I might just start adding more repositories here, right? So they will look similar to this, of course, not the same repositories. Let's just do one. So we have metaphysi, which seems like, okay, metaphysi is the username, infinite scroll is the repository name. Metaphysi, let's quickly do one. Let's grab this information, 6.8K, so that's 6,800 stars. And the repository URL is infinite scroll. Okay, and then you keep going. So you can look at the third topic and the fourth topic and so on. Now, what I really want to get is I want to get a CSV file, because the CSV files are the files that can be read very easily and processed using Python for data analysis or machine learning. So if I go file, export, download CSV. So that's just going to download the current sheet as a CSV file. Okay. And let's just open it up here. Let's see if we can open. Fine, let's open it up in a text editor. Well, let's see if we can open it in VS Code here. So we take this file, open with any text editor will do, but here. So this is what a CSV file looks like. So it has a header. And this is the header row. It tells you that the first element in each row is the repository name. The second element is a username. The third element is a number of stars. And then the fourth one is a URL. And here's one example. 3.js is the repository name. Mr. Doob is the username. 69,700 stars. And this is the link. And here's the second example, and so on. And this is the repositories for 3D. So maybe we can just call that 3d.csv. right? 3D is the topic, so let's just call that 3d.csv. Similarly, once you download this, this is going to give you the repository ajax.csv. Okay. All right, so now we know what we want and we can now start writing code. So let's get into that. First thing I'll do is I will go to jovian.ai. Now, if you're not logged in, you can click the sign up button and log in. It's really straightforward. And on jovian.ai, I can now create a new notebook. Jovian also provides a free cloud computing environment, so you don't need to set up anything on your computer. You can if you want to, but you don't have to. So now let's click new. You can either click new here, or if you're on your profile, you can also click new notebook right here. But let's click new and let's click blank notebook. And let's call this web scraping live project. Or let's give it a more appropriate name, GitHub. So scraping GitHub topics repositories. Okay, your name on the project name on Jovian will have lowercase letters and hyphens. And I'm going to keep this public, but if you want to work on something privately, you can also select a private notebook here. And let's click create. Okay. So what does that do? Now, what that does is it creates a Jupyter notebook. And I'll tell you what a Jupyter notebook is. And it now opens up that Jupyter notebook for you to view. So you can see this is what you're seeing here inside this box is a Jupyter notebook. This is, you can either have some title or some explanations here, like this is a title and this is some explanation, or you can have code here. So this is some code and this is some code and this is some code. Now what you're looking at right now is a read-only version of the Jupyter notebook. Okay, this is because to execute the code of a Jupyter notebook, we need to have a Python interpreter running somewhere. So we need to have some machine either running on the cloud or on your computer. So to run this notebook, what you can do to execute this code is simply click the run button here and click run on binder. So you click the run button and click run on binder. That will set up a machine for you on the cloud. So on binder.jovian.ml, we will set up a machine for you free of cost. And then we will install all the required Python libraries, and you will see that it takes a minute to install a whole bunch of things. So we'll install a whole bunch of Python libraries for you so that you don't have to install anything. And then we will start this Jupyter notebook server, and we will take this notebook and put it into that server so that you can start editing it and you can start executing the code inside it. And you can then save a version back to this project. So you see right now we are at version 1. And I'll show you how you can create version 2, 3, and 4. So every point, wherever you have something interesting, we will save a version of the project. Okay. All right. So this is what it looks like. Let me just zoom in there a bit. I guess this is about right. And yeah, so this is what a Jupyter notebook looks like. Now on a Jupyter notebook, you can see that if I double click here, I can edit some of this code. Let's R or let's execute this code, right? So you can see that I can edit this explanation that simply by double clicking. And then once I want to save the edits, I can just click the run button here and that's going to save the edits here. Or I can press shift plus enter and that's going to save the edits here. And similarly here we have some code. So let me just write 2 plus 2. This is a Jupyter notebook cell. And I'm just going to run 2 plus 2 and that is going to print out the output 4. Okay. So you write some code here and then you either click the run button or you press shift plus enter to write some output out of it. So that's a Jupyter notebook. Quick introduction. Let's give it a title. Top repositories for GitHub topics. Okay. That's what our project is called. And we now need to come up with a strategy on what we want to do. So let's come up with a quick strategy. The first thing that I'll do is I'll just copy over some of the instructions from this notebook here. Okay, so the first one is to pick a website and describe your objective. So I'm just going to create a new cell here and I'm going to convert it into a text or a markdown cell. And I'm going to just put in this section here, pick a website and describe your objective. Inside it, I'm going to take these and make them to-dos. so that these are things we can tick off. I'm just going to put them in a list here. Let's grab the second one. And let's just put the headings right now, and we will later put in all the details so that we can start writing some code. Yeah, so that's step 2. Let's grab the third one. Use beautifulsoup to extract information. Let's grab the fourth one. Create a CSV file. And let's grab the fifth one, document and share your work. Now, why am I doing all this? Why am I not starting coding already? Because a project is almost never completed in a single session. It takes time to complete a project. Sometimes it takes weeks. So what you want to do is you want to set yourself up for success and first figure out what you need to do. Spend a bunch of time planning. And here we've spent about 20 minutes planning. That's not a lot. You can spare that for a project that will take a few weeks. And just write out what you need to do so that the next time you come back to this project, you are in execution mode, you know exactly what to do. A lot of projects fail or get stuck in between because you lose clarity about what you want to do. Okay. I'm just going to hide this header here so that you can see things a bit more clearly. All right. So now we want to get the top repositories for GitHub topics. The first step, we've browsed through a site and picked a topic, pick something to scrape. We've done that. So let's just write that here. So let's say we are going to scrape, well, we are going to scrape this page github.com/topics. So this is sort of the strategy, or let's call it outline. So we're going to scrape github.com/topics. From the topics page, what we will do first is we will get a whole list of topics. So you have 3D, Ajax, algorithm, AMP, etc. They're organized in alphabetical order. So we're going to get them in alphabetical order. So we'll get a list of topics, and for each topic, let's see, we'll get what information should we have for each topic. I guess we can grab the topic. There are two things. So there is the command line interface, which is like the topic title, but then there is also this thing in the URL. This is just called CLI. So topic title, and let's call this topic ID. Okay, so topic title, topic ID, or how about we just get the entire URL instead of the topic ID? So topic ID and topic page URL. And maybe let's also get the description, topic description. Just while we write it, why not? Then for each topic, we'll get the top, let's say top 25 repositories in the topic from the topic page. So the topic page is CLI, and on CLI you have all these repositories. And as we've created the CSV here, repo, so here we have for 3D, we have 3.js, and we have libgdx and a whole bunch of these. So for each repository, we will have the repository name, username, stars, and repository URL. So for each repository, we'll grab the repo name, username, stars, and repo URL. Okay. And one thing we'll do is for each topic, we can create a CSV file. So for each topic, we'll create a CSV file. And let's just put the format of the CSV file here as well in the following format. All right. And what is the format of the CSV file? Well, let's open this up. Where is that? Yep, here we go. So this is the format of the CSV file. So we're just going to put that here. Okay, so that's our project outline. Let's give that a nice header. And with that, we have now browsed through a site that we want to pick, that we want to scrape. We've identified the information that we'd like to scrape. We've decided the format of the output CSV file, and we have summarized the project idea and an outline of our strategy. So that's not bad for 30 minutes. We are already 20% done. And now what we want to do is just implement the strategy step by step. So the first step is to use the requests library to download web pages. Now what's requests? Let's just Google that. So requests is a library for downloading web pages. This is what it looks like. You say request, you import the request library, and then you say request.get, and then you give it a URL. Interestingly, they're using a GitHub as an example as well. And then of course you can give a whole bunch of things, but this is really the easiest way to use it, request.get, and that's going to give us some output. So let's begin by installing the library. How do you install it? There, this is how you install Python -m pip, or if you know a little bit of Python, you know that you can also just do this. So just come here, and we need to run this on a terminal to install it. But here's a quick tip. If you're inside a Jupyter notebook, just put the exclamation mark and put a command. And what Jupyter will do is whenever it sees the exclamation mark as the first character, it says that, okay, this is not Python code. This is some code that you want me to execute on the system directly within the terminal, or what is called the shell or the command line. So it's going to take this command directly and then pass it on to the system without thinking of it as Python. So if we just do pip install request, and I'm just going to upgrade the library if it's already there, that's going to install the library for you. So you can see here that the request library was installed and downloaded. What I like to do when I'm installing things inside Jupyter notebooks is I just do QUIET quiet, because I don't want to see the output. And if there's an error, it will still get printed, but the successful output will not be shown. Okay, now what we can do is say requests, import requests. So that's going to import the request library. Now the first step, remember here, is to scrape. We want to scrape github.com/topics. Now scraping has two parts. You get the information, you get the web page, and then you parse the web page. So let's get the web page. So first let's grab the topics URL. The topics URL is github.com/topics. And remember, in URLs, you always want to make sure that you have this HTTP or HTTPS part in the beginning. So github.com/topics, we have the topics URL. And then we need to download this URL. The way to download it, as we just saw here, the way to download it is simply to do requests.get. And when you do request.get, that creates what's called a response object. So let's do that. Let's call it response equals requests.get. And let's put in the topics URL here. And that's it. In just a second, what requests has done is it has opened up the URL, taken that web page and downloaded it. And now if you want to see if this response was successful, you can type response.status code. And response.status code here is 200, which means that this request was successful. Now, any request that you make using a URL, whether it is within a browser or using Python, every request culminates in a response which contains some content and a status code. The status code indicates whether the response was successful. And if you want to learn about different status code, just Google HTTP status codes. I think MDN is a good resource, but let's just put HTTP status codes. And here on HTTP status codes, you can see what are all the different status codes that an HTTP request, which is simply downloading a URL, can result in. So if you have a successful response, your status code will be between 200 and 299. So whenever you do request.get and you get a response, just check the status code of the response. All right. Okay. Next, what about the actual content of the web page? All of this stuff, where is that? Well, that is inside response.text. So when you type response.text, that's going to print out here all the content that is there on the page. Now, I will not recommend printing out the entire response. But what we can do is we can first check its length. And I'll tell you why I'm not recommending printing it out. So when we do length response.text, we see that on this page, there are 126,000 lines of 126,000 characters. Now, if you try to type response.text and try to display all the 126,000 characters, that's going to be a bit much for this browser tab to process, and it may slow things down. So instead, what we can do is we can just look at the first few lines. So let me just call this web page, or let's call this page contents equals response.text. And here you can do page contents. And let's just look at the first 1,000. Let's make that 1,000. So here's what the contents of the page look like. You see? So the page that you saw here, github.com/topics, this entire page is actually this content. This is written in a language called HTML. And what we can do is we can even save this to a file called HTML. So let's save this. Let's do with open webpage.html for writing as f.write. What's that called? Page contents. So let's write all the page contents to a file. And that's it. So we've just written page contents to a file, and we can go file open. And you can see that now with my Jupyter notebook, I have this file webpage.html. Now, if I want to edit the file, I can select it and click edit. And now I can see the entire contents of the file. So you have this whole doc type HTML, and then you have a whole bunch of HTML tags, and then you have a whole bunch of meta tags, and then you have a whole bunch of links, and this is all HTML content. This is what HTML looks like. Okay. But if you want to view this web page in its rendered format, remove the tick box and just click on it. And now you see that I'm on hub.binder.jovian.ml, which is the same server as the Jupyter notebook. So I'm on the same server as the Jupyter notebook. And here, when I open up this page, I can see here this exact same page which I saw on GitHub. But of course, this is not on GitHub. This is a local copy of the file that we have downloaded on our server. Okay. So this is how your browser shows it, but this is how a HTML file actually looks. And what we need to do is we need to grab the right information out of this HTML file. So that's the next step. Remember, on this HTML file, we have on this page, we have this information like 3D and Ajax and all featured topics and so on. So what we want to grab is we want to grab the word 3D. We want to grab the link which 3D points to. And we want to grab 3D modeling is the process of virtually developing the surface, etc., etc. Of course, none of the links will work in our local copy because we just have this one page. And then we want to grab Ajax, then we want to grab this description of Ajax, and we want to grab the link to Ajax and so on. So to grab this information, we need to use a tool called beautifulsoup. So how do we install beautifulsoup? Well, one simple way to find out is just to search it online. So let me just close a few tabs here, and we will then install beautifulsoup. Okay. And by the way, this is exactly how I do things when I'm working on a project. I try not to remember anything. I just Google things. This is how you install beautifulsoup. You say pip install beautifulsoup 4. And this is something, again, it's hard to remember that you need to put a 4 at the end. So I'm just going to grab that link here. I'm going to say pip install beautifulsoup 4. And I'm just going to say upgrade, and I'm going to say quiet. That's going to install beautifulsoup for me. Next, I need to import it. So let's see. Beautifulsoup documentation. Okay, that looks like the documentation of beautifulsoup. How do we use it? Well, here's a quick start. It says that if you have the string which represents an HTML document, now in this to parse the string, all you need to do is you can first do this from bs4 import beautiful soup. So you can see that sometimes these Python libraries can have confusing ways in which they work, because the library's name is beautiful soup. The package that you need to install is called beautiful soup 4. And then the package that you import is called bs4. The module that you import is called bs4. But anyway, that's just how this library is implemented, and you can easily look it up online. And this is why I try not to remember things and just look for them when I need. Okay, so we've installed beautiful soup, the package 4, beautiful soup 4. The module in this package is called bs4, and from bs4 we are importing the beautiful soup class. And now to actually parse some HTML, this is how we do it. So we take HTML doc, which refers to a string, and we put that into beautiful soup, and then we use html.parser. So beautiful soup can parse other things as well, XML and JSON, etc., etc. But we want to do HTML parsing. So because web pages are HTML code, as we saw here, this is all HTML. So let's parse that HTML code by putting in beautiful soup HTML doc. Of course, the content in our case is called page content. So I'm just going to grab that variable name and put that here. And this is going to be our parsed document. So let's just call that doc, and let me run that. And that's it. So now beautiful soup is parsed, and you can see doc is, oops, probably shouldn't have done that. So doc is a beautiful soup object. Inside it contains all the HTML in a parsed format. So you can see that doc is of the type beautiful soup such and such. Okay. All right. So now we have a beautiful soup object. Now we can actually find things inside the web page by doing some queries. How can we do queries? Well, let's look at an example. Let's maybe find out what is the code corresponding to this specific section, or maybe let's look at 3D. Okay, let's try and grab 3D out of this page. So one way you can do that is by right clicking on any element in the browser and clicking inspect. And this works in Chrome, this works in Safari, this works in a whole bunch of browsers. So once you click inspect, it opens up this, what's called this developer tools pane. Sometimes it opens up at the bottom, sometimes it opens up on the side, and you can see, you can change where it is located using this option here. I generally like to see it halfway somewhere below the screen so that it does not affect the sizing of elements here. But we want to grab 3D. So this 3D here is looks like it is inside this HTML tag called P. So it is inside this HTML tag called P, and this HTML tag has certain attributes. So it has the attribute f3, lh, condensed, etc., etc. This is the value of the attribute class. And then there is another P here, and then that P contains the description. Okay. How about we just grab, what do we do? Well, so now this is where we have to figure out what exactly do we want to select. How about we try and grab this? Okay. So let's find this P tag. And the way to do that is I can do P tags equals doc.find all, and just find all the P tags. And you can see that this is a, where is that? Yeah, this is a P tag here. So this is inside a P tag. So let's just grab all the P tags by doing docs.find all P tag. And we have all the P tags here. Now we can just check what, let's first look at the length. How many P tags were we able to find in the doc? So there are a total of 67 P tags. But of course, on this page, if you were to count, you don't have 67 different topics. You only have about 20 or so, which means that we are probably grabbing far more tags than we need, because this is also a P tag, and there may be other P tags. So we may have to get a little more specific, but let's look at the first few P tags here. So let's do P underscore tags, and let's look at the first 5 P tags. So you can see that the first P tag is called browse popular topics on GitHub. So that's probably this. And you can verify that by clicking inspect here. So looks like this was also a p tag, but of course this is not something we are interested in. Let's see what the second p tag is. The second p tag is called bootstrap. Okay, where do you see bootstrap? Okay, bootstrap is probably a topic. So bootstrap is somewhere here. There you go. Yeah, bootstrap is a topic, so that's great. Then the third p tag seems to be this bootstrap is an HTML, CSS and JavaScript framework. Okay, looks good. So it seems like we were able to get some of the tags or some of the elements from this HTML page corresponding to what we want, but some of them weren't. So how can we get more specific? Well, one thing we can do is we can search for this specific class. So if I go back to 3D for a second. Yeah, on 3D, I'm going to go back here and I'm going to just check for this specific class f3 lh condensed mb0 mt1 link primary. And there are two ways to search for a specific class. One way to do it is to specify this dictionary of attributes, and we can say that this class should match this. Let's split that into a couple of lines so that it's a little nicer to read. Or how about let's just create a variable out of this. So let's call this selection class. So this is one way to do it. You can say doc.findAll, and then you can specify the tag that you want to find, and then you want to specify the key, and then you want to specify the value it should have. So the attribute on the tag and the value it should have. Now for class specifically, there's an easier way to do it. You can type class underscore and then provide the class name. So this is a slightly smaller syntax, but it does the exact same thing. But just to be more generic, I'm just going to use this notation. And this time it looks like we found 30 p tags. Okay, I think we might be getting there because 30 p tags probably means that there are about 30 topics on this page. So I think we have found exactly just the topic titles. So let's just check that. Let's check p tags. And you see here, we see 3D, Ajax, algorithm, AMP, Android, Ansible, and so on. So we've already obtained the p tags corresponding to the 30 topic titles. Okay, not bad. What else can we do here? Let's try and grab the topic descriptions. So let's see, instead of calling them p tags, let's call this topic title p tags, or let's call this topic title tags. Topic title tags and topic title tags. This is one thing I love about Jupyter notebooks. You can go back and change variable names. Of course, it messes things up sometimes, but it's just very nice to be able to edit your code as you're going along. Okay, so these are all the topic title tags. Let me just print 5 here. Next up, let's get the topic descriptions. I'll do the same process here. I'll right click here and click inspect. And here you have, the class is slightly different, but it is still a p tag. So I'm going to do topic description tags, and I'll just say DESC doc.findAll p. And of course, this time I want the class to be, let's call that disk selector. Okay, and that should give us the topic description tags. Let's take a look at about 5 of these. So yes, it does contain the p tag. Inside it, which contains the topic description. 3D modeling is a process of virtually developing the structure and the surface and structure of a 3D object. This is the description of Ajax. This is the description of algorithms. So it corresponds to what we see here. So now we have topic title tags and we have topic description tags. What else do we need? Well, we also need this URL. We want to get the URL to the topic page because from the topic page, we are going to download more things. So how do we do that? Here is one technique to do it. If you look at this p tag is inside a div, and then that div is inside this a tag, and this a tag has the required href. So if I get maybe the first topic title tag, let's get topic title tag 0, which is simply topic title tags, and the 0th element out of that, element at position 0. So that's the p tag corresponding to 3D. What if I type dot parent here? So dot parent gives us the parent of this p tag, which is this div, which inside it contains a couple of p tags, the title and the description. So now we have the title and the description here inside this div. What if we type parent once again? Okay. Well, that probably went too far. I don't know. Let's check the parent of this. Somehow that doesn't seem right to me. Fine, let's just get the div tag, and this is the div tag, and let's just try parent once again. Okay, that's not doing it. And these are the kind of problems that you will run into when you're doing web scraping. I'm not sure why this is happening. One thing we can do is we can go into the source code and see what's wrong. So we have 3D here. So you have 3D, and 3D contains this div. And somehow when we check the parent on this div, it doesn't give us this a tag for some reason. Well, how about we just directly fetch this a tag? Okay, so that approach did not work out. Let's click inspect once again. Let's find this a tag. So this a tag has a class, no a deflex and no underline. So how about we just check for this? Let's do topic link tags. Let's get rid of this. Let's do topic link tags equals doc.find or find all. Find will just give us the first one, a, and this will have the class deflex, no underline. Let's see how many of those we got. We got 30 of them. So fortunately in this case we did not have any other a tags which had the exact same class, but suppose they did, then you can also check. You can also look for the a tags which contain only the data GA click attribute. Okay, so Beautiful Soup contains all of these ways to find parents, find children, find tags, and most of the time find all does the job. But suppose it does not, just read through the documentation and find a way to do it. If not, search online. So you can say Beautiful Soup, how to get parent, and just search that and find out. So there are both of these ways. You'll refer to the documentation, search online, but ultimately what you want to do is find a way to get all the information that you need. So now we have the topic link tags, and let's just quickly verify that we got the right information here. So let's do topic link tag 0. Okay, so this is in fact the link to 3D. Yeah, so this is the link to 3D here. Okay, and if we just check href, and this is how you get the href attribute. Remember, this is an a tag, and inside it has a whole bunch of other tags. We're not too interested in that. We're just interested in the a tag and the href of that tag. So we can just get the href of this one tag using the href key access. You can see it has the href /topic/3D. So now if you put github.com, if you were to put https, so let's just make that topic 0 URL as https github.com plus the href of the first topic tag and simply print that topic 0 URL. That prints github.com/topics/3d. So we can now open this new link in a new tab, github.com/topics/3d. And yes, now we are able to construct the URL to the page, to the topic page for the topic 3D. Perfect. So now we have all the information. Let's now just clean it up a little bit. We have these topic link tags or topic title tags. Remember, these have these p tags. Out of each p tag you get this. We just were interested in what's inside this tag, and the way to get what's inside this tag, let's just get one of these tags. So this is the first one, the first p tag. The way to get what's inside this tag is simply to do .text. So if you do .text, now we just get back 3D. So here's what we can do. Let's say topic titles, and we want to create a list of topic titles. So now we can do for topic or for tag in topic title tags. Let's get the tag, and from the tag let's get the text, and let's append that to topic titles. So let's do topic titles dot append tag dot text, and that's it. And let's just print topic titles here. And now what we've done is, from a list of topic title tags, which were p tags, we get each tag, and for each tag we get the text out of the tag and add that to a list, and now we have a whole list of topics. Not bad. Suppose we also wanted to get a list of topic descriptions. Let's create an empty dictionary here. Let's do that in a new cell. So topic descriptions is empty, and then for tag in topic description tags, we do once again, well, let's just do topic descs topic desks dot append tag dot text, and let's just print out topic desks and see what that looks like. Okay, looks like we have all the information, but you can see there is this empty space here at the beginning. There's an easy fix for that, just called .strip, strip. The strip method of a string simply removes any space from the beginning and from the end. So these are all the topic descriptions. Let's just look at the first 5 here, so because there's a lot. And finally, there is topic URLs. So let's create topic URLs for tag in topic URL tags. So that's topic link tags. So for tag and topic link tags, here we are interested not in the text but in the href attribute. So we said topic URLs dot append tag, and we want the href attribute of the tag, and we can now see the topic URLs. Of course, these are not the full URLs. These are just the these are just the paths. We need to add a base URL, so we can add a base URL here. So let's say base URL is github.com. So let's simply add base URL here. Okay, so these are all the topic URLs. You take this and we can remove the quotes and open it up, and you can see here now we have the list of topics for Android. Okay, step 1 is done, which is getting information, getting the list of topics from the topics GitHub page. Of course, we just have the first 30 topics, and we'll talk a little bit about how to get more, how to get all the topics. You can see that we're only covering from A to C here. We have a lot more, but let's just first create a small CSV file out of these, and then we'll talk about what to do next. Okay, so to create a CSV file, one trick is we can use a pandas data frame. So I'm going to do this. I'm going to do pip install pandas. Okay, minus quiet, and that's going to install the pandas library, which is often used for data analysis. I'm going to import pandas. Pandas is typically imported as PD, so I'm going to import pandas as PD. And then I can create a pandas data frame. So let me call that topics data frame, or data frame is normally abbreviated as DF, as pd.dataframe. And I want to somehow take each of these and make it one column in a table. So the way to do that, I believe, is pandas create data frame from lists. Create a pandas data frame from lists. Okay. So suppose you have this list. You want to convert a single list into a data frame. You just say pd.dataframe list. But suppose you have suppose you have two columns. So let's say here is list 1 and here is list 2, and you want to use them to create two columns. So what you can do is you can zip them and call columns. Okay, I think there's an easier way to do it. Yeah, this is the one to do it. I like this one. So you have a list of names, just as we have a list of topic titles. You have a list of degrees, just as we have a list of topic descriptions. You have a list of numbers here, just as we have a list of topic URLs. And then you create a dictionary where you give the name of the column and you give the list. You give the name of the column and you give the list. And you give the name of the column and you give a list. And it's going to create this table for you. Okay, this table-like object. So we have, let's first create the dictionary. Topics dict is the first thing we're interested in, topic name, and let's just call it topic title. Let's just call it title. It's clear that it's related to topics. So we say topic titles. Then let's call it, let's get the description. In description, this is topic DESCS. And of course we have URL. So let's just call that URL. This would be topic URLs. I guess topic page URLs. I'm not sure. Topic URLs. Yeah. That's the topics dictionary. And if you want to verify, just type that and check the value. Looks fine to me. Let's just put it into pandas. Topics df. Okay. And I'm just going to now open up this topics df data frame. So now just to quickly revise what we have done so far. But let's look at the table first and then we'll quickly revise. So now we have this table, this pandas data frame it's called. It's basically like a spreadsheet table, not very different, where one column is title, and this title is the name of the topic. One column is a description. This description is once again the description about the topic. And finally, you have this URL. This URL is the URL of the topic. Okay. How have we done that? Step by step. And of course, we want to go further and we want to get the information of top repositories for each topic. But this is step 1, right? So step by step, how have we done that so far? We decided which page we are going to scrape. This is github.com/topics. Then we use the request library to download that page. You can see we took topics URL and got that using request.get. Then we looked at some of the contents of the page and we realized, of course, it's HTML. All web pages are HTML. To parse this HTML, we use the beautifulsoup library. So in the beautifulsoup, you import the beautifulsoup library, give it some contents in a string. So the contents of the page, you give it in a string and you parse it as HTML by specifying html.parser. Then that gives you this parse document. From that document, we then looked at how this page is structured, and specifically we clicked on the thing we're interested in and clicked inspect. That brought us to this p tag, which contains the topic title and it contains a certain class. So we got the topic title and we got the class, and then we used doc.findAll. It's all part of beautifulsoup. You can check the documentation. There's a whole bunch of functions here, but findAll is the easiest. You specify what tag you want to search and you specify what attributes you want to search. So in this case, the class selection class was able to do this for us. That gave us the list of topic title tags. So these are the topic title tags. We applied the same strategy this time for topic descriptions. So here we do inspect and this gave us topic descriptions. So this is a topic description. So we got the p tag and we gave it this class to search. That gave us the topic descriptions. Then we got the topic title tags or topic link tags. And if I just print one of them, oops. Yeah, if I just print one of them, you can see this is what the topic link tag looks like. Okay. And then we got, what we saw was that out of each of these tags, we need to extract some information. For example, from a link tag, we are interested in the href attribute. So we get a topic link tag, get the value of the href attribute. And this is the way to get the value of attributes. And then we can also add a base URL at the beginning, and that can be used to construct the topic URL. So that's how you now extract information from tags. So you are parsing it, then you're searching, and then you're extracting information. Similarly, for getting topic titles, well, we have these tags. For each tag, we simply get the text of the tag, and that gave us the topic titles. Similarly, the topic descriptions, this is how we get the topic descriptions. And once we have all of these, so we have a list of topic titles, we have a list of topic descriptions, and a list of topic URLs. Here we have constructed topic URLs once again by using a loop. Now we can put that into a dictionary. So we create a dictionary with the keys as the names of the columns that we want to create in our table, and the columns itself, the values go here. Then we can create a pandas data frame using pd.dataframe and passing in the dictionary, and that creates this topics data frame. Now creating a CSV from this is really simple once you have this. In fact, maybe I should take some of this code and put it down, but creating a CSV out of just a list of topics is really simple. You say topics.df.toCSV. So you say toCSV and you specify the name of the file. So topics.csv. Okay, and let's open up, let's go file, open topics.csv. And you can see you have title, description, URL, and you have title is 3D and 3D modeling is a description, and then you have the URL of the topic as well. Now, one other thing you will see is the 0, 1, 2, 3, 4 that shows up. This is also the 0, 1, 2, 3, 4, which is basically the row number. Now, if you don't want row numbers to show up, which you probably don't, you can just type index equals none, and that will take away this information. Now you see you just have title, description, URL in the CSV, and you have 3D modeling is the process of such and such, and then you have an HTTP link. And at this point, if this was your web scraping project, just getting a list of topics from GitHub and their descriptions and their page URLs, you would be done. So in some sense, we've completed a mini web scraping project here, but we want to go a little further. You want to go to the next step and go to each topic page and then get some information out of the topic page. Okay. So how about at this point, I don't need this information. I can change this title to getting information out of a topic page. Okay, so how do we get information out of a topic page? Let's get a single topic page URL. So topic page URL is, well, topic URLs 0. That's a topic page URL. Let's open up this topic page URL. This is the topic page for 3D. I think we already have that. So this is the page. It has some information, and then it has a whole bunch of repositories. So how about we start by just repeating the same process. So we get response and requests.get topic page URL. Okay, let's check the length. Let's check first if the response was successful. So status code. The response status code was 200, not bad. Response.text. Well, first check the length. Okay, this looks pretty large. It has 579,000 characters. So I probably don't want to print it. But what we can now do is we can now put that into Beautiful Soup. So let's call that doc2, or let's call that topic doc. Topic doc is Beautiful Soup. response.text and html.parser. Now I remember this only because I've done it just now, otherwise I would be looking it up. Now we have a topic doc. Okay, let's try to get the information about the first repository. So there are three parts to it. There is the username, there is the repository name, and of course, since this is a link, the link is also important. And then finally you have the star count. So let's get the username first. Let's click inspect. So here now we have this link tag or this A tag which represents this username. So I'm just going to find an A tag. Let's find username tags as topic doc dot find all A tags, but of course there can be many A tags on the page. So what we really want is we want some of these classes. So let's see what class this A tag has. It has some hydro, data hydro, etc, etc. It doesn't seem to have a class, and this information seems specific to this particular repository. So that's probably an issue. Let's do one thing. You have this A tag and then you have this second A tag, and they're both inside this h1 tags. So maybe let's get this h1 tag and then we can look at the children of this h1 tag. So let's grab the class for this h1 tag. Okay. And I come back to my notebook, and this time I'm looking for not for A, but I'm looking for h1. And the class that they should have is, well, h1 selection class is h1 selection class. And these are no longer the username tags because they have both the repository and the username. So let's call them repo tags. Okay, so we have repo tags. That's quite a few. I should probably check the length first. So we got exactly 30 repo tags. Now you can look through this page and you can see that there are exactly 30 repositories. So that means for each repository, there is an h1 tag which contains the username. It contains the repository name. Let's go back up and you can see here. So it contains the username, it contains the repository name. And in fact, this A tag also contains the link. If you check the href here, href, that also contains a link to the repository. So this has a whole bunch of information. And let's check the first repo tag. Repo tags 0. So inside this repo tag, this first repo tag, you can see that this is an h1 tag by itself, and inside it has this A, and it has this another A, which has the username and the repository name and the href. Well, one thing we can do is we can do find all A, and that should give us 2 A tags. So inside the first repository tag, we have 2 A tags, this one containing the username, this one containing the repository name. So if I get A tags 0, that should give me the first A tag. So that is giving me exactly this. Okay, so you may need to just navigate around a little bit using selecting the right thing and then either selecting the parent or the children or something like that. So here we selected the h1 and then we got the A tags inside it, and then we used the first A tag here to get the username information. So if I do A tag 0 dot text, that's going to give me Mr. Doob. Of course, I will want to strip it. Next, we can do A tags 1 dot text dot strip. Let's look at A tags 1. So that's the name of the repository. Do dot text dot strip. And this is the wonderful thing about Jupyter notebooks. You can type code step by step and then you can keep cleaning it up as you go. Next, we also want the repository URL. So let's get A tags 1 once again. And in this case, we have the href. Okay. Remember, we had this base URL. We had this base URL, which was github.com. Or if you don't, let's just define it again. github.com. So if you do base URL, so repo URL is base URL plus A tags href. And let me just print repo URL. So now it seems like we have been able to construct the URL to open the repository page. And this is the top repository for the topic 3D. Okay, so we're working with a topic URL. We extracted the topic URL web page. We found the right elements inside it, which contain the information that we need. And then we extracted that information by doing this processing. Okay, so we got the base URL out of it. All right, so now we have, this is the username, this is the title, this is the base URL, or the repo name, and this is the base URL. Or this is not the base URL, this is the repo URL of the repository. One last thing we need is the number of stars. Let's grab that as well. I'm just going to click inspect here, and there you go. So it looks like this is an A tag, and this A tag does contain some class. So it contains a class called social count float none. So I'm just going to do that. A tags equals a star tags equals topic doc dot find all. You have the A tag, and then you have the class social count float none. Let's check the length of star tags, and by this point we know that there should be 30 of these. Yeah, and that's just a quick validation that we extracted the right information. So let's look at star tag 0. Okay, this is the A tag. I can probably get the text out of it. Okay, I can do strip. All right, so it looks like this is now I have 69.7k. I probably want to convert this into a number. The quick way to do that is to define a function. Well, let's say parse star count. So you get a star string, something like this. And what you can do is you can first strip it. And so it's always to just strip strings whenever you're doing these conversions. So I'm just going to strip it. Then I'm just going to check if the last character, which I can get by star string -1 equals k. So if the last character equals k, then I can take this. So let's say this is stars str. Let's first work it out with an example, and it's easier to create a function later. So here the last character equals k, right? You can check this, stars str -1 equals k. But if I want to get everything except the last character, I can do this colon -1, and that's going to select everything before the last character. So I get that, and then I can convert that into a float, and that should give us 69.7. But of course, we also have to account for the k. So I'm just going to take that 69.7 and multiply that by 1000, because k means 1000. So that gives us 69700. Of course, the number of stars will be an integer. So what we can do is now, once we've performed this calculation, we can simply convert that into an integer. So I'm just going to convert this into an integer and return that. So if the last element or the last character of the star count is a k, then that means we leave the last element out, the last character out, convert that into a floating point number like 69.7, multiply that by 1000, and then convert that into an integer. If it's not, then it's going to be something like this. It's going to be 697. Okay, if it's something like this, then converting it to an integer is really simple. You just do int stars str. So we just do return int stars str. Okay, so now we have this function parse star count. So we can say parse star count, and we can take all of this information and put it inside here. So now we have 69,700. Okay, looking good so far. So let's define a function get topic or get repo info. Okay, let's define a function get repo info, which takes an h1 tag. Remember, the h1 tag contains information about the repository. I am talking about this h1 tag. Yeah, I'm talking about this h1 tag. So repo tags 0. This h1 tag contains information about the repository. and then it also takes a stars tag. So it takes a star tag, and this returns all the required information about a repository. Okay, so get repo info is a function that I'm defining. What does it do from the h1 tag? Well, first it gets a tags out of the h1 tag. So we can say h1 tag dot find all a tags. Then it can get the repo, so it can get the username. So username, remember, that is something that we get as a tags 0 dot strip. Then we get the repository name. Remember, that is a tags 1 dot strip. Repo name. Then let's get the repo URL. The repo URL, remember, is base URL plus a tags 1 href. And finally, let's get the star count. So the star count simply is, well, you have the star tag, stars equals, okay, and then we're just going to return username, repo name, stars, and repo URL. So now we've defined this useful helper function get repo info. All it takes is an h1 tag and a star tag. So remember, we have these repo tags which are all h1 tags. You can see that this is one h1 tag and this is a second h1 tag and so on. And similarly, we have these star tags which are all a tags, each one representing a single star. So how about we take repo tags 0, star tags 0, and put that into get repo info. And that gave us Mr. Doob 3.js 69700 and the link to the repository. This we have done for the first one. So we can do this for everything. So how do we do that? Well, we do for I in range len repo tags. So length of repo tags is 30. So what we do is when we do range len repo tags, it creates a range of 0 to 30. So I is then going to take the values 0, 1, 2, 3, 4 all the way up to 29, not 30. So as I takes the values 1 to 29, we can get some repo info here. Repo info is get repo info, repo tags, star tags, and 0. And let's create a topic repos dict. So this is going to be a dictionary which is going to contain information like username. So it's going to contain a list of usernames. Then it's going to contain some information about the repository. So let's call it repo name. A list of repo names. It's going to contain a list of stars per repository. And finally, it's also going to contain repo URL. So it's going to contain a list of repository URLs. So we get some repo info and repo info, and now we can just do topic repos dict dot get username, and to this list of usernames we can append repo info 0, because remember, repo info, it gives you 4 things. The first thing it gives you is the username. Then similarly to this list or to this dictionary, we can now append to the list of repo names, we can append repo info 1. To the list of stars, we can append repo info 2. And finally, to the list of repo URL, we can append repo info 3. And it says this is invalid syntax because, oh, I need a colon here. List attribute has no attribute. Oh, typo. And a typo everywhere. Let's fix the typo. Okay, so let's check repo tags. Not repo tags. Let's check topic repos dict. Topic repos dict. Oops, it looks like we got the same username everywhere. That's because I should be getting the repo information for the repo tags number I. So let's just get repo tags I and repo tags I. Yeah. Now we have all these usernames, Mr. Doob, libgdx, etc., etc. And then we have all the repo URLs. And then we have, yeah, and then there's more, but it's not printed here. So we can convert that into a data frame, pandas data frame. So you have topic repos df is pd.dataframe topic repos dict, and then topic repos df contains the username, the repository name, the number of stars, and the repository URL. Not bad. And we have about 0 to 29. So we have 30 top repositories for the topic 3D. Remember, we are all this while we are working with the topic 3D. You can see here where we got started, we are working with the topic 3D. Now, of course, we want to do this not just for the topic 3D, but we want to do it for all the topics. So the way to do that is to convert this into a function. So what we should be doing rather than doing this is, should we define a function get topic repos, which takes a topic URL, and it can get first, let's see, it's going to request and get the topic URL, and then if response.status code is not equal to 200, then that means there was an error. So we can just raise an exception, failed to load page. Okay, and if it is, then let's create a topic doc. We can say topic doc is beautifulsoup response dot text and html dot parser. Now from the topic doc we can get we need two things. We need the repo tags and we need the star tags. So let's grab the information for the repo tags and the star tags. These are the repo tags, so let's just pull that in. These are the repo tags, and let's get the star tags as well. These are the star tags. So this is what you always want to do in a Jupyter notebook. As soon as you've done some work and you need to repeat that work, just create a function. So here, and we can even, the way to write a function is even first you can write some comments like download the page, check successful response, parse using beautifulsoup, then here we are saying get h1 tags containing repo title, repo URL, and username. And here we have get star tags, and finally we can now get all the repository information. So we can take this link, this for loop, put it here, just indent it properly. Quick tip, if you want to indent multiple lines, just select them and press tab or shift tab to indent them forward or backward. And I believe we are done here. So we can now convert that into a data frame. So let's say return pd.dataframe topics repo dict. Of course, we need to also create a topics repo dict first. So that would be this. Okay, that was too much. There you go. So now we have a topics repo dictionary. So this is all the code that we have, which is downloading a page, checking the successful response, getting a topic doc, getting the h1 tags, getting the repo tags, the repo h1 tags, creating a topic dictionary, and then parsing the repo information. Okay, I think this function is getting a bit too large, so I can probably split it into two functions. So let me just do get topic page, which takes a topic URL, and let's take this part and just make that a part of this, and this can simply return the topic doc. And then in get topic URL, we can simply take the topic doc. Okay, so we have this get topic page, we have get topic repos. I think I'll also copy over get repo info, just so that I have all my code at one place. So we have get topic page, given a topic URL, it's going to download the page, check whether it was successful, and then get the information using parse it using beautifulsoup. Then we have get repo info, which takes an h1 tag and star tag and gets the information for a repository. And then we have get topic repos, which is going to get the h1 tags that we need, create a dictionary, and then just go over all the information here and add them to the dictionary, and finally convert the dictionary into a pandas data frame. Okay, so how about we try this out with another topic? Remember, we have this topics df, or we have this topic URLs. So from topic URLs, let's get maybe the second URL. Maybe let's get, which one? Let's get maybe one of the 5. Let's get number 4. So let's call it URL 4. Okay, so first we'll get topic 4 doc using get topic page URL 4. Okay, small issue here. This should say response. Next, we can get the repositories using get topic repos. So topic for repos, this would be get topic repos, topic for doc. Okay, let's check topic for repos. And what was topic 4? Well, we can simply check URL 4 here, and that should tell us. So topic 4 was Android. Topic for repos, let's see here. There seems to be some issue here, because it seems like we fetched the same things that we are getting for 3D. Let's go up here. Maybe there is some information. This should say topic URL, not topic page URL. And let's try that again. So you always want to test your functions. And now you see here that for the topic Android, the top repositories are Flutter, which has 118,000 stars. Then you have just Java C, which has 78,000 stars. Then you have Jenny Mobile. Well, actually, this is the name of the repository. You have SCRC Pi by Jenny Mobile, which has 47,000. Then you have Awesome Hacking, that has 43,000. You have Material Design Icons by Google, which is 42,000, and so on. And you can just replace this with any other topic URL, and that will give you the information that you need. Or we could also do all of this on a single line. Let's try to do that. So we get a topic URL, and then we get the topic page for the topic URL. And then we get the topic repositories for the topic page, which is now a beautifulsoup document. And let's check that. So we got the 4th topic page URL, Android. We got the page for it using and parsed as a beautifulsoup document. Then we extracted the information from it and created a pandas data frame, which you're looking at. Let's check another topic. Okay, so here we have, what's topics 5? Angular. So this looks like all the Angular projects. What's topic 6? Ansible. So this looks like all the Ansible projects and so on. And of course you can save it to CSV. So you can say to CSV. This is Ansible. So you can say ansible.csv and index equals none. And let's go file open. You see ansible.csv. For ansible.csv, you can see that we have the username, repo name, stars, and repo URL, which is matching the CSV format that we had started out to create. Okay. Maybe let's continue cleaning things up a little bit, because what we want to do now is let's write out how to scale this. So we will do first, we'll write a function, a single function to first get the list of topics from the topics page. Then get the list of top repos from the individual topic pages. Create a CSV of the top repos for the topic. And we want to do this for all of these. So for each topic, okay, so let's do that. So let's write a function. It's always a good idea to first describe what a function should do in English before you start typing it out. So let's say scrape top repos or let's just say scrape topics, just to be very simple, or scrape topics repos. Naming functions is hard, but try to be as clear as possible. So we're saying scrape for all topics, all the top repos. So scrape topic repos. First we need the topics URL. I think the topics URL, we already have something, but let's just create it inside. So we have the topics URL. Then we need to scrape the topic. Now we've written a bunch of code to do that already. So let's just do def scrape topics. Okay. Scrape topics is simply going to do take the topics URL, and then from the topics URL is going to get, so requests.get topics URL, and this is going to be response, and I'm just going to reuse this here if there is an error. So if response.status code is not 200, I'm going to raise an exception. I'm going to go back up all the way and copy over some of the code that we were using earlier. So once we get the URL from the topics, then we do this. So we get the topic title tags here, and then we get the topic description tags as well. I'm just going to collect them all together. Okay, then we have the topic link tags. So let's just get that information too. This is a quick tip. As I'm going through a Jupyter notebook and collecting code, I like to insert a new cell, paste the running code there, copy the new code, and then cut that code away. And then we have this code for parsing information as well. So let's just take that too. Then we have this code for parsing descriptions. I'm just going to grab that too. I'm just putting all the code together so that we can do it in one function. Then we have this code for parsing topic URLs. Let's grab that too. Okay, I think that should do it. So now we have all the code. to scrape a single topic. I'm just going to put that here in this function. Okay, that looks like a lot of code. Let's clean that up a little bit. So we have topic titles, we have topic descriptions, and topic URLs. So here we are still going to go to github.com/topics, and from there just get a whole list of topics first, right? We're going to get a list of topics. Now these are all still a little bit too large, so let's just script the functions. So let's do def get topic titles, and this is going to take a doc, and it's going to first select these topic title. It's going to select this information from the topic titles doc. I don't know why that happened. Okay, then we are just going to take we don't need that anymore. Then we are just going to create this list, topic title tags, and just return this list. Okay, so now we have this function get topic titles, which takes a BS4 beautiful soup 4 doc, and it returns the list of topic titles, not topic title tags. So let's just put topic titles here. So that should give us a list of topic titles. Similarly, we can do that for descriptions. So we do get topic descriptions from a doc. This is the description selector. This is the description tags. Then we can get the topic descriptions. And then we can get the topic URLs as well. Well, first let's return this. Let's do def get topic URLs from the document. So all we're doing here is just a little bit of cleanup, so that when we face issues, which we will, I'm pretty sure, since we're doing this from scratch, when we face issues, we can fix them more easily. Okay, I think we're almost there. So we have get topic titles, get topic descriptions, get topic URLs. So we can simply return, or we can create a topics dict, which is, well, it will have title. This will be get topic titles doc. Then we have description. This will be get topic descriptions doc. Then we have URL. This will be get topic URLs doc. So we create this dictionary, and then we simply return pd.dataframe topics dict. Okay, how about that? How about let's just test that first. So we've taken all the code that we had written so far, and we have just converted that into a bunch of functions. Finally, the function we need to invoke is scrape topics. So, okay, so scrape topics, what it does is it takes the topic URL, it does request.get to get that response. It checks whether the response is successful. Then it creates this dictionary by calling get topic titles. Get topic titles is going to grab p tags with this class, and then from each p tag it's going to extract the text, and that's going to give us the topic titles. Similarly, we have get topic descriptions. Similarly, we have get topic URLs. Then we have scrape topics, which is going to take all that and create this dictionary, and then put that dictionary into a pandas data frame. And of course, this is what it looks like. So we have about 30 topics, and we'll talk very briefly about how you can go beyond that. But that's step one. So now we have scraped the topics. So we have this function scrape topics, which is going to get the list of topics from the topics page. So let's write our mega function, which is scrape topics repos. So for the first thing we'll need here is the topics df, or the topics data frame, which is simply by calling scrape topics. Okay, so we call scrape topics, and that gives us a data frame containing a list of all the topics. Then we want to get the top repositories for the individual topic pages. How do we do that? Well, we can do it this way. Let's define a helper function here. Scrape def scrape topic. This is going to take the topic URL and the topic name, and it's going to first create a data frame. So for this topic, it's going to create a data frame by calling get topic repos on get topic page from topic URL. From the topic URL, we get the topic page. From the topic page, we get the topic repositories, which is going to a data frame. And then we are going to write that to a CSV file. So we're simply going to say topic df.save topic name plus .csv and index equals none. Okay, so we have scrape topic. So let's do that. First we scrape topics, and then for we want to do it for each row, right? So how do we get a list of rows? From a data frame. I guess you could simply do, so we have topics df here. There's a list of data frames. You can do for row in topics df dot iter rows. I guess you could do something like this. Yeah, this should do it. So then each row will have the title, description, and URL. So if, for example, we just printed the title, or if we just print 0 and 1, okay, let's try that again. Let's just search loop over rows in pandas. How to iterate over the rows in pandas? Well, for df dot rows, you have iter rows, which is used something like this. Okay, let's just do that. Let's try that. Index comma row in df dot iter rows, row title and row description, and this would be topics df. Yeah, I think this should do it. So we have the row title and then we have the row description. Of course, we are interested in the URL. So this is how you iterate over the rows in the pandas data frame. So for index comma row in topics.df.iter rows. So we have for index comma row in topics.df.iter rows. Then we need to call scrape topic, which is here. So we call scrape topic on the topic with the topic URL and the topic name. So we say row URL, and I think it's called title here. So row title. And let's just add a print statement here. So scraping top repositories for the topic to the file name. So we're just going to print that here, and we're just going to put in row title. Well, you know what? Let's just keep the title here. Okay. So now we've defined a whole bunch of functions. We've defined a bunch of functions to get information about all the topics, which is using this scrape topics. And then we've defined a function to get information about all the repositories for a topic, which is this get topic page, get repo info, get repo topics. Let's just move that one line so that's a little more compact. All right. So moment of truth here. Now if we call scrape topic repos, it should, let's also say print scraping top topics from GitHub, scraping list of topics. So it should print scraping list of topics, and then it should scrape the top repositories. So I'm just going to call scrape topics repos. Okay, there is a question, save. There's no attribute save. Yeah, this should be called to CSV. So you see here, we are starting to scrape files, and if things are going right, we should start seeing some files being created here. So we have 3D, Ajax, algorithm, Android, Angular, Ansible. All of these topic repositories are getting created. And you can check here that you have coding interview university. This has 163,000. So this seems like this would be a reasonable thing to have to be a top repository for algorithms. In fact, we can check it out here. So you see here, it does have algorithms in the tags. So we have first scraped the list of topics from GitHub, and then we have scraped the list of top repositories. And at one point it failed to load a page, not sure why. But this is where now, and then additional task for you is to start checking, because some of these requests can fail. So additional task for you is to resume the download. Now let's say you have already downloaded for a certain topic. You can add a check here. So you can add a check where we have scrape topic. You can check if this file name does not already exist. So let's say we create this file name, fname equals topic name.csv, and if, let's import OS here, import OS, and let's do if os.path.exists fname, let's do not, fine, print the file such and such already exists, skipping dot format fname, and just return, otherwise downloaded. Okay, what's that? That should be fname. Okay, so you see here for 3D, Ajax, etc., it was able to automatically it was able to detect that we have these files. So we've skipped those, and now we're downloading the remaining. So for about the top 30 topics on GitHub, we have been able to scrape the top repositories. And with that, we've just created a data set. Right. One thing we can also do is we can also just put them all into a folder, and I'll let you figure that out. It's very easy. You just have to create a folder. You can do that using, I think, OS or shutil, one of these modules. So just Google how to create a folder using Python. And then in that folder, you can put all these files. So now we've generated this file, which contains some information which can be useful for analysis. And of course, you can download this. If you want to download this, you can just download this here. So here I can download it as 3d.csv. And if you want to download an entire folder, well, you can zip it. Again, zipping folders is also possible within Python. But let me do one thing. Let me just put them into a folder so that I can show you one last thing, which is how to save your work to Jovian. So I am going to put them into a folder here. So how about we do, first we create a folder so we create a folder here. So we have os.mkdir or os.makeDirs. Let's check makeDirs. So we can do this. Let's do import OS and let's just check the documentation for os.make_dirs, and we can check documentation using help. So you give it a name and then you give it an exist. Okay, so this checks if it exists, and if it exists it skips. So I'm just going to do here print or just do os.make_dirs, and let's just see topics. Let's just create this folder data, keep it simple, exists okay equals true. So we're going to create this folder data and we are going to put this information inside the folder data. Now I'm just going to change my scrape topic function a little bit. Instead of creating the file name here, I am going to just take the direct file name directly, and in fact it's not going to be the file name, it's going to be the full path, which is the directory name / the file name.csv. And what we can do here instead, and let me just execute that. So whenever you change a cell, some code in a cell, just execute it as well. So now I'm going to come here and create a repository, and then over here I'm just going to say data / plus row plus .csv. Or a nicer way to do that is using string formatting, which is data / empty.csv.format row title. Okay, so now we are creating this directory. Before we do this, so let's run it one more time. Now hopefully we should create a directory. Exist, I think it's called exist. Okay, fname. Okay, what's fname? This should say path, this should say path, this should say path, and that's it. Oh wait, this should say path. Okay, so now it should start scraping. And we've also put into place the check if the file already exists, so that we can resume if there is an error at any point. So let's let that run, and in the meantime let's do a quick review. And really all the code that we need is there here. So this is the code. So let me just call this final code. Final code. Okay, so here we have one function to take a topic URL and get a topic page, which returns a beautiful soup for doc. Then we have one function here which takes a topic doc and gets a list of repositories for that doc. To get the list of repositories, we get a whole bunch of h1 tags, a whole bunch of star tags, and then we use this get repo info function, which takes an individual h1 tag and individual star tag and returns the information for a repository. So we use this in a for loop. We get all the information about a repository and then put it into this dictionary that we have created, which is a username, repository name, stars, and repository URL. And finally, we return a pandas data frame out of this. Finally, we put that all together into this function called scrape topic, which takes a topic URL and a file path. It checks if that path file does not already exist. It gets the topic page from the topic URL, gets the topic repositories, gets the topic data frame, and then it takes the topic data frame and converts it into a CSV file and writes it to the given path. Of course, we set index equals none because we don't want the row numbers to show up in our CSV file. That's what you do for one topic. Now to get the list of topics, we have the scrape topics function, which looks at the github.com/topics page, gets a response, creates a dictionary, and converts a data frame. This data frame will contain information about the topics. Then of course, internally it uses get topic URLs, get topic descriptions, and get topic titles. So each of these selects certain tags from the page and grabs the information out of those tags and creates a list. And finally, we have this mega function scrape topic repos, which puts everything we've done into a single function, and we just invoke this single function. And here it has downloaded all the repositories. Now we can see there is this folder called data. In this folder data, you have all of these repositories, and that's our data set. Now, one last thing I will tell you is how to save this work. Now on Jovian, whenever you're on hub.binder.jovian.ml, remember that this is free compute and free compute is limited. So what you want to do is at regular points, you want to do import Jovian if it's not already imported and run jovian.commit. So when you run jovian.commit, we simply capture a snapshot of this Jupyter notebook and upload it back to your Jovian profile. Remember, we created a Jovian notebook in the beginning. So we're simply going to update a new version of that notebook. So it's doing that, and it's automatically going to include some of the other files you are going to use as well. So let's give that a few seconds because we have a whole bunch of files here. But what you want to do is you want to keep running jovian.commit from time to time so that you keep recording snapshots of your work. Okay. And while that runs, I just want to talk briefly about documentation, and then we'll probably look at a few questions. So how do you want to document this? Now, the way I like to do it is first write all the code in a basic Jupyter notebook, which is almost like a rough notebook. Oh, there it is. So you write all the code in a rough notebook, and then you create a new notebook and copy it over line by line, step by step, with adding proper documentation. Okay. And we'll talk about that, but let's just see here. So now this is saved, and you can see that we now have version 2. Of course, you should be saving versions every 10-15 minutes or so. Don't wait for 2 hours. And here we have all the files that we downloaded. Okay, so now if you want, you can download the whole thing as a zip file. So it's going to create a zip file and it's going to download that for you. But yeah, that's how you create a simple data set on Jovian. Okay, you just do jovian.commit, and that's going to, yeah, this is our zip. Let's just open up that zip. There's our zip file. Inside the zip file, we have all the files that we have downloaded. Okay. Yeah, so let's talk about documentation. So I like to look at this one as a rough notebook because here I'm just figuring out everything that I need to do. But at this point, what you can do is you can just call it rough. And then I'm going to actually create a new notebook. So I'm going to go new blank notebook, and let's see, let's call that scraping GitHub topics repositories. Create that new empty notebook and run it. And that's going to take a minute or two to run. Let's get rid of all this in the meantime. So we are going to take things. Yeah, so this was so we are going to take what we have done here. This was the original notebook that we've created. It has a whole bunch of stuff, and we're going to then move it into Binder step by step. Okay, so we are going to first give it a title, scraping the top repositories for different topics on GitHub. Okay, now here you may want to just include some introduction. So I like to just put in a to-do about the explanations. So the way you think about it is your Jupyter notebook should contain enough information for somebody reading it to understand what you are doing and how to replicate your work and why it's important. So you may want to do an introduction about web scraping. So introduction about web scraping, what web scraping is, introduction about GitHub. So you can just say GitHub contains a whole bunch of repositories, millions of repositories, and just the problem statement. We are going to use the topics page, and from the topics page, we are going to find the list of topics for each repository, and then we are going to download it in not too much detail. And then you want to talk about the tools that you're using. So mention the tools you are using. The tools would be, we are using Python, we are using requests, we are using beautifulsoup, and we are using pandas, right? So that's the step one. Now, at this point, if there are any images or any links, you can mention those links as well. For example, you can mention the link to the GitHub page. You can mention the link to the documentation of different libraries. Then the next thing you should mention is outline. So you should mention an outline of the project. So here are the steps we'll follow. And fortunately, we have an outline already. We have an outline right here. So we have an outline right here, project outline. Actually, it'll be easier to grab it from this page. Again, this requires some cleaning up before presentation, but now we have an introduction. So this is the intro. So now we have an introduction. Now we have the steps we are going to follow. And you literally take the steps that we are going to follow and convert them into sections. So let's call that scrape the list of topics from GitHub. Okay. And here once again, explain how you'll do it. So once you come from an outline into a section, in each section, you do the same thing. We are going to scrape github.com and we're going to get a list of topics. And for each topic, we'll get the topic page URL and description. How are we going to do it? Well, roughly speaking, you're going to use requests to download the page. Then you're going to use BS4 or beautifulsoup. Let me just call it BS4. Of course, we'll expand on this later. BS4 to parse and extract information. And then we're going to convert it into a pandas data frame. We're going to convert it into a pandas data frame. And then you can start copying over some of the code. So let's just go directly to these functions that we've created. And let's start with get topic page. Now here is where it depends on how much depth you want to get into. You can either introduce the function directly, and you can say that let's write a function to download the page. Okay. And you can then write the function, and in the function you can have some responses, and then you can maybe show an example. So let's say get topic. Oh, this is not that, sorry. This is the wrong function. The function should be what's the function? Well, maybe we can take this and put that into a function. Yeah, I may have missed that. So maybe we can take this and put that into a function. So let's say def get topics page. So this is the topics URL, and it's going to create this doc and then return this doc. And you can add some comments here. Okay, so now we have this get topics page. So here you're doing just enough. Every function that you create should be about 5 to 10 lines of code, not more than 5, maybe 7 lines of code, not more than that. So this, what it does is it simply takes, it returns a beautiful soup doc, which contains a parsed web page, which points to the list of topics on GitHub. So you can get the information out of it. You can say get topics page and get the doc out of it. And of course we need to import requests, and we need to import from bs4 import beautiful soup. Okay, and you can see here, and you can get this doc, and this doc worked fine, and you can just show that this doc has a type. Oops. So you can just quickly show that this doc has the type beautiful soup, and of course from this doc you can get information, like you can do doc.find a and such. Okay, and here you want to just add some information, add some explanation. So now you're building a story. You're saying that, okay, this is what we're going to do. We're going to download it using request. We're going to convert it into a BS4 doc. And let's then talk about parsing information from a topic page. So to parse information from a topic page, we can take these functions. So let's take each of these functions. Let's clean it up a little bit. And let's say that let's create some helper functions to parse information from the page. And then you can put in these functions: get topic titles, get topic descriptions, get topic URLs. Okay, so try to put not more than 1 or 2 functions per cell, and then add some explanation above it. So now we have this. Now we have this function get topic titles. So you can say that get topics titles can be used to retrieve the list of topics. So let's just say get topic titles can be used to get the list of titles, and we can say titles are get topic titles doc, and let's just check the titles. So these are all the titles. Right now, of course, you don't, whenever you have more than 10 things, you just want to do titles and then maybe just print the length and print the first 5 elements. It's not very useful to print out 30 or 40 things. Okay, so now we've added some explanation. We are saying that we are going to create a helper function to pass information from the page. At this point, it may even make sense to just have maybe a screenshot explaining why you are doing this. So how to get screenshots? Well, you do github.com/topics. And let's say we grab this, we say 3D and we click inspect. And what we want to show is that 3D, the topic title, is part of this P tag. And I can just take a screenshot of this point, of just this piece, probably something like that. And let me just take that screenshot, put this on a site like imgur.com. So I'm just going to, okay, let's just try that again. I am going to take a screenshot. Yeah, so now I have the screenshot. Then the screenshot clearly shows that the P tag with this class corresponds to this image title, this topic title. So I'm just going to grab this URL here and put this into my notebook, my final notebook. And you can say some explanation about to get topic titles. We can pick P tags with the class, and of course whatever class it is, right? And then you can just show that as a screenshot. You can even talk a little bit about developer tools if you want. So the thing is, you decide how much detail you want to get into in your explanation and who you're writing for. And it's always a good idea to keep a certain person in mind, whether it is a friend, if you're trying to explain it to a friend. So write it as if you would explain it to the friend. Assume that they know what they currently know, and you have to fill in all the gaps. You know what your friends know, so you may have to fill in the gaps there. or you can write it from the perspective of explaining to your parents, your mom, for example. In that case, you probably don't want to write too much technical explanation and you want to make the explanation more high level. Or if you want to explain it to somebody, maybe a professor, then they probably already know many of these things, but you want to tell them that you understand these things, right? So there you can get more technical and you can cover things in a bit more depth. So understand your audience, who you're writing for, and based on that, if it's a potential employer, then you can write it as if you're writing to a friend. So understand who you're writing for, and based on that, decide how much explanation you need and how detailed or how technical you need to make it. In this case, I can add some explanation that we can find out that this is a p tag and this has a certain class by right clicking and then clicking inspect and such. And then now we define a function. Similarly, we have, so just as we have done for topic titles, we can say similarly, we have defined functions for descriptions and URLs. And then you can give the topic URLs. So you can include an example here. Perfect. We have some topic URLs, and then finally we have this whole scrape topics to put it all together. So now we can say, let's put this all together into a single function, scrape topics. Okay. So we created this section, scrape the list of topics from GitHub. And we have explained step by step. First, we're going to get the topics page. Then from the topics page, we're going to inspect in the browser and we're going to get topic titles, topic descriptions, topic URLs, and then we're going to scrape topics and create a single data frame. Nice. Next, we can create a second section, which is essentially the second point in the outline, which is, well, we've covered the first two. So get the top repositories in the topic from the topic page. So get the top repositories, let's just say from a topic page. Okay. And once again, to do explanation and just the steps that you're going to follow. And we can, the code is here. So I'm just going to grab some of this code. You have the topic page. So I'm just going to put the topic page here. And of course, then you want to show that you can get a topic page. So you do get topic page for https github.com/topic/3d. Now you can then copy over get repo info. Now you can talk about the h1 tag. So let's put a to do here. So talk about the h1 tags. And how so then we have get repo info. So you then show an example. So that's all it is. You write a function, show an example, write the next function, show an example. So once again, you write this function to do show an example. And finally, you have this thing, scrape topic. You take that. Of course, when you copy over, you may have to make a few changes because you may discover certain errors or some things that may have gone wrong. One good thing to do at the very end, once you're done with the notebook, is just do kernel restart and clear output, and then run each cell one by one from the beginning, from the top to the bottom, just to make sure everything runs properly. But yeah, you have the scrape topic function, and then to do show an example. Okay. So we got the section 1, which is scraping the list of topics from GitHub. Section 2, which is get the top 25 repositories from a topic page. And by the way, in between, keep doing Jovian and jovian.commit so that you can keep saving these snapshots every now and then. So scraping GitHub topics repositories. This is what it's looking like so far. Looking good. Of course, there's more explanation that can be added. So we have the list of topics which is scrape top list of topics from GitHub. We have the top topics for a repository, and now we can just put it all together. So we can literally call the section putting it all together. How do we put it all together? Well, it's actually not that difficult anymore, because we can simply do this. We can just say that again, we have a function to get the list of topics. We have a function to create a page, to create a CSV file for scraped repos from a topic page. So let's create a function to put them together. And this is the function that we put together. And now we simply invoke scrape topic repos. And you can say that let's run it to scrape the topic repos, or the top repos, for all the topics on the first page of github.com/topics. Okay. And then you run this, and that's going to download all the things, all the topic pages, create CSVs. Of course, you can add some description about, we can check that the CSVs were created properly. How do you do that? Well, you can read a CSV using pandas. Of course, here I haven't created any CSVs, but I can do that here. I can do pd.read CSV and go to data/android.csv. You can just display a data frame. So read and display a CSV using pandas. Okay, do that. And then you finally once again do import Jovian, jovian.commit. So that's that. Now, one last thing you should do is you should always add a summary and further reading or future work. Well, actually, references and future work. Here you can include a summary of what we did. You can include references to links you found useful. And then you can finally include ideas for future work. Each one is a list of things that you want to have. And this is an important section, because this says that everybody understands that you cannot really complete everything that you cannot really do everything that's possible with a data set. But it's not obvious if you don't state it whether you've thought about it or not. So that's why you always have this future work section, where what you want to say is, I have done all this because this is the amount of time I had, but these are some other ideas that I have which I could have implemented if I had more time. So you're showing that you have the skills and you have the insight to think about future work. And that it's a trick, because for the person reading, now they're already imagining that, okay, you've done so far, you've done all this, and you know what needs to be done next. So that means you will be able to do it. And that is what employers are looking for. Employers, like when you share this with a potential employer, or let's say you're applying for an internship and you share this project in your resume, you want to tell them that you have the right skill and you can take this to the next level. You can apply it to any problem, and you can think through a problem and come up with the next steps. Okay. And just like that, let's do jovian.commit once again. So just like that, we have now created our web scraping project from scratch, and it has been less than 2.5 hours. And we've also been talking through it. We've done a lot of experimentation. We've done a lot of debugging. So it's really not that hard working through a web scraping project. Of course, it may take you a few days or a few weeks, because you may not have the amount of practice, or you may need to look things up, or you may run into some issues, but that's perfectly fine. A project of this size, you may want to take about a week to 10 days to do it, and every day you want to spend maybe an hour or so. And that's where having this rough notebook where you decide an outline is very helpful. And then once you're done with the rough work, you want to create this nice final notebook. And you can also put an image here, maybe a nice banner. You can add an introduction about yourself, about the project. You can add more details here. There's a lot of places where more explanation can be added. But in terms of structure, this is all pretty good. That you're talking about your state, introducing the problem, you are describing the outline. Each step in the outline becomes a section. In each section, you have some explanations. You show good coding practices by creating functions. Now you can hide all that rough work behind in your rough notebook, but in your final notebook, you're showing that you write functions. And by the way, nobody starts out by directly writing functions. Everybody understands that. You experiment and then you create a function. So it's okay. It's not like you're cheating in any way if you're just showing your functions here. It's just how things work. You experiment, you figure it out, and then you put it all together into a single function. And then you go function, and then of course with each function you explain what it does, you show an example, then you write the next function, you describe why, you write the function, and then you use it and explain what it does, show an example. You write another function, explain what it does, show an example. Then you define a function that uses all the previous functions. So you want to cap off every section with one sort of mega function which combines everything you've done in that section into one line of code. And that's a very powerful idea, that we just say get topic URLs, or just that we just say scrape topics, and that's going to go to that page, get the page, extract the information out of it, create a dictionary and convert that into a pandas data frame. So it takes everything we've done in the section, reduces it to one line of code. Then we say, okay, we now have a list of topics. Let's talk about getting top repositories for individual topics. You write a function, you introduce the steps, then you write a function, you use it, you give an example, write another function, use it, give an example, write another function, use it, give an example. Then you put it all together into the scrape topic function. Once again, we've summarized this entire section into a single function. Nice. Next, we put it all together. So we say we can get a list of topics. We can get the repositories for a topic. Let's put them together into this function, scrape topics repos. This is a small section, and let's run it. And this is the final show that we are showing you, that we just run this one line of code and it's going to go and scrape GitHub and create all of these CSV files for us. And finally, we just save that. And then we talk about, okay, what we've done so far, just a quick summary, just as we did right now. You want to summarize that in text. These are all the references that you used, all the documentation links, or the pages that you scraped, etc., etc., and then ideas for future work. Okay, and that's pretty much it. That's a web scraping project. I hope you found this useful. Now, one last thing I want to mention for web scraping is it's a great thing to do when you're creating data sets for research or for academic work. But some websites do not allow scraping. So just check their policies, and definitely many websites do not allow scraping for commercial purposes. So if you're planning to do something commercial out of web scraping, do contact the website once before you start scraping. The other thing is, if you scrape too many pages, maybe hundreds of pages, then they may start blocking you. So be careful about that, and do check, just be mindful, what is too little or too much, right? If you're downloading an entire website, that's probably bad. But here GitHub contains millions of repositories. We are getting maybe a few hundred. That's not too bad. But even there, I would say maybe stick to scraping less than 100 pages, not more. Okay. Now, one last exercise for you here is, you would have noticed that this page only contains the first 30 topics. How do you get the next set of topics? Well, I'll tell you, but I'll let you figure out how I figured this out. But if you put $page equals 2, you will see here that you have topics starting from cryptocurrency onwards. Then if we go to $page equals 3, you see here, then now we have topics starting from G onwards. And then we go from page number 5, and that will have some of the remaining stuff. And then we have page number 6. Let's go 6. Oops, 6. Page number 6. Yeah, so that goes up to STUV WX. Let's see if we have a page 7. So you have 7 pages. So what you can do is you can take all the 7 page links and use that to get a list of all the featured topics. Of course, page 8 is empty. You will see here. So that's how you get the list of all the featured topics and not just the first 30. Then similarly on a topics page, like on XML, you have about 30 repositories on the first page. You can see that the first repository is sheet.js. What you can do is you can type page equals 2 and get the next page of repository. So this is page 2. You can see this is web API client and YQ, etc. So you keep going page 2, page 3, page 4, and that way you can keep getting multiple pages from a repository. This is page 20. Of course, there'll be a lot of pages. So now the exercise for you is try and maybe get, if you want to do this, try and maybe get all the topics, and for all the topics get maybe the top 100 repositories, so that you will have to go over maybe 3 or 4 pages. Okay. Otherwise, if you want to build your own project, then there is this link, web scraping project guide. Check the project ideas section here. There are about 16 different ideas. So you can check out all these project ideas. Remember the steps. Pick a website, describe your objective, use the request library, use beautifulsoup, create CSV files, document and share your work. Of course, once you have published your work, let's just publish that once again. You can then take this notebook and you can tweet it out. So you can go on twitter.com and then tweet it out. Live web scraping project, and just tweet that out and do tag Jovian ML. And we are retweeting 3 great notebooks every week, and we're also picking the best notebook or the best project of the week, and we are sending you a swag pack. So if you are working on a web scraping project, please do tweet about it. And you can also include some hashtags like hashtag data science. Twitter is a great way to just get an audience for your work. So hashtag machine learning. Well, this is not machine learning really, but hashtag Python. Let's say hashtag web scraping. Okay. And you can take the same thing. You can also post it on LinkedIn. So that's a very nice and easy way to take your Jupyter notebooks and put them on Jovian by running jovian.commit and sharing them online. You can also, of course, take this link and put this in your resume or in your LinkedIn profile, or just share it with somebody when you're applying for an internship. So now they can see that you know web scraping. They can go through your project and they can evaluate if you are right for the job. But of course, the onus is on you to make this a great project. So take your time with your project. Every project that you work on, 50% of the work is completing the code and getting an output. 50% of the work is presenting it and making it readable, making it reproducible. So somebody who is reading you through your project should be able to completely reproduce it by running it. And they can do that by just clicking the run button. Okay. So that's all we have for today. Thanks a lot for joining. This was a long workshop, but yeah, we will take some questions now. Let's see. Let's take questions one by one. We'll answer maybe around 10 or 15 questions. Okay, one question is, can you save this data into a database? Yes, you can. So it's not very difficult. You just need to know a little bit of SQL and you need the database credentials. So if you have the database credentials and the tables have been created there, you can save it directly to a database. I don't have one set up right now. Okay. This workshop, is there any internship available on Jovian? Well, we do not have internships at the moment, but if you do build great projects, we will send you a swag pack. And just putting projects on your Jovian profile is a good way that will help you get internships anywhere. Can we fetch images also? Yes, you can. Yes, you can. So for instance, on sheet.js, you have this image URL. You have this image in, let's just say open image in new tab. So this is an image URL. So you just get an image URL and you can go in, you can just do requests dot get the image URL, and this is the response. And of course you can check r dot status code. It's 200. And now you need to write that image URL to a file. So you can say with open with images. You wanna, what was this? Well, was this a PNG? Let's just check. I don't know. I think this might be a PNG, but we can check it in the network tab. If I reload here, it should tell you that this is it says image/jpeg. I don't know if you're able to see, but it says image/jpeg here. So this is a JPG file. So we can, well, we can go with open image.jpg, and we want to write it. And for images, you want to add WB because it's a binary file. It's not a text file. So you just do f dot write, and for an image file, you do f dot write r dot contents, I guess, or content. Yeah, r dot content. You can look it up how to download a image using requests, but let's check if we have image.jpg. So we do have image.jpg, and image.jpg is this file. Okay, so it's not too different. You just say request.get, and then while writing, you just want to put in the right extension. You want to include b to indicate that it's a binary file, it's not a text file. And then you write r.content, not r.text, because there's no text inside the image. Of course, you could just have looked up download image using Python requests. How do you get the image URL? Well, the way to get that is you are typically looking for some kind of an img tag. So if you have doc and you do doc.findAll img, so let's see img tags. So you have img tags 0. You see, so in an img tag, you have this src. Let's maybe check maybe the 20th image. Yeah, so you have this src, so you can get the src attribute. So that's going to be your image URL. So img URL equals src. And now you can put this img URL here instead of this full image, right? Let's just print that img URL and let's see what that looks like. Yeah, so that contains bash. So that's how you get images and save images. So you can absolutely download images as well. Will we be able to complete today? Well, I hope so. Are there any security implications? Yeah, you should probably just check the website's terms and conditions. And in general, you probably don't want to scrape for commercial purposes. How do you run and open a new cell? Well, to create a new cell, you click outside. You don't click. So here right now we are editing the cell, but if you click right outside, you have selected it, but you're not editing it. If you press A, that's going to create a new cell above. If you press B, if you press B, that's going to create a new cell below. Shift enter is how you run it. Okay, say we need 16 movie titles, but due to H2 tag, I get 24 tags. How do you filter them? So you keep selecting the attributes that make sense. Sometimes you have to select the class. Sometimes you have to select some other attribute. Sometimes you have to select maybe the parent. So you can always do some kind of checks. Just look at them visually and then think about how you can separate them out using code. Sometimes you may have to get all 24 tags, and then out of those 24, filter the 12 that match your criteria by checking some of their attributes. Okay, struggling with pages which automatically load continuously. Yeah, so if your pages have what's called client side loading, where they show a loading screen and then they load on the browser, that's going to be a bit tricky. Web scraping with requests works only for those pages where the server directly sends you HTML with the content. But if there is a loading bar that shows up for a few seconds, then requests will not do it. Then you may want to check out something called Selenium. You may want to check out a tool called Selenium. Selenium, what it does is it creates an entire fake browser for you. And in that browser, it allows JavaScript execution. Request, of course, does not allow JavaScript execution. So it's going to load the page, let the JavaScript run, let the loading bar complete, and give you a result. Okay, then please do subscribe. We are doing one live session every week. So do subscribe if you want to stay updated. We have workshops like this one where we build projects from scratch, and we have a few more videos, such videos on our channel. We also have some AMAs with data science professionals like data analysts, machine learning engineers. We also have AMAs coming up with people who have just landed their first data science job. So you can learn about their journey, and probably that is going to be a lot more useful if you are yourself looking to make a career in data science. So do subscribe and do invite your friends also to check it out. Can we get the load time of the pages in the CSV as well? Yes, I think you can. I think if you check a response dot time, I don't know if it has time, but requests response load time Python, I believe. Okay, you may have to do elapsed. Yeah, elapsed is so you do elapsed. So that tells you the amount of time. And how do you convert that into seconds? Well, let's see. Elapsed dot let's say microseconds. So okay, that seems like too much. Elapsed dot total seconds. Yeah, so it took 1.42 seconds. So you will have to get that from the response, the time required to load the page. How can we get repos from other pages? I think we covered that. You just add a page parameter. I'll let you figure out how I found that out, because it's not very straightforward that you have to put a question mark page parameter equal to 3 or something. But every page, there will be some way to paginate it. There will be, because all of these pages are set up to be crawled easily by Google, etc. So if you just scroll the page a little bit, one thing you can do is you can click inspect and then check the network tab. Maybe scroll down here, and wherever you see this load more button or automatic scrolling, just click that and see what happens here. So you can see here what happened. So such things will help you out. How can you get the total number of pages? Sometimes you can't. Sometimes you just have to keep trying and see if there is any space, if there is something to be found on a page or not, if it contains any information or not. Okay, Tanya says, I just got to know about this channel. Please guide me if I want to switch my career into Python. So for those of you joining for the first time, do go to jovian.ai and start checking out some of the courses we have. So we have some free courses, and then we have a paid bootcamp coming up as well. So do check out the Zero to Data Analyst bootcamp too, especially if you're interested in making a career switch. So from our perspective, the way we've created this bootcamp is, if you have a little bit of programming and maths knowledge, then you can become a data analyst in 6 months. And this 20-week program is decided to help you get there. So do check it out. But otherwise, if you want to learn data science in your own time, and this is a part-time bootcamp, by the way, so you can do it while learning or studying. But if you want to learn data science in your own time, then you have some free courses on the Jovian platform as well. So do check it out. On our YouTube channel, we have some videos that will help you plan your career in data science. So if you go to videos, let's see, there's one you can check out. This one is called How to Build a Career in Data Science in 2021. Let's see if I can find that. Yeah, so we have one on how to build a career in data science. Yeah, how to start a career in data science. This is one you might want to check out. Let me just post the link to that video. There's another one we had recently, which was about how to write a resume for data science. So it was how to craft a job winning resume. Do check out that as well. I'm just going to take these and post these in the chat. But do check them out on our channel regardless. Using Beautiful Soup 4, is it possible to crawl millions of Yelp web pages to fetch review image URLs? Well, if you try to crawl millions of web pages, then Yelp is probably going to block you. So probably not. Don't do that. And for research purposes, probably a few thousand might be okay. If you really need to crawl a million, then it's better to reach out to their support and check with them and explain to them why you need to crawl a million pages. How can we access the notebook? I will share the notebook as well. I will share the notebook with you as well. How did you delete cells? You click outside a cell and you tap DD twice. That's going to delete the cell for you. Can you do a video on multiprocessing, multi-threading and async IO? Yes, possibly in the future. Keep coming back every week and soon we might do one on that topic as well. How do you handle login and scrape the data from inside it? Okay, so there have been a couple of questions, one about using tokens and one about using logins. It's a little bit trickier when you want to scrape data that requires a login, but generally how it's done is whenever you are logged in, the website stores a cookie or a token in your local storage. So it either stores a cookie in your browser or it stores a token in your browser's local storage. And every time a request is made to the website from your browser, that cookie or that token is included. That cookie tells the website that somebody is logged in on that browser and who that person is. So the website can take that cookie. Using that cookie, it can retrieve your information and send it back. So what you need to do is you need to get the same cookie. You can grab it typically from your browser in developer tools, and you can include it with the request that you make. So when you do request.get, alongside you can include a cookie as well. In fact, and sometimes it's a cookie, sometimes it's a token. In fact, if you check the documentation of requests, you will see that they have an example of fetching GitHub user information from the GitHub API. And here they have included some authorization, which is user and password, right? So you may have to do something like this. It may not exactly always be auth. Sometimes it may be some cookie, sometimes it may be some header, sometimes it may be something else. It depends on website to website. You'll have to study what happens on each website and then replicate things on a per website basis. But that's how you do it. One guide that I will recommend is just check out, let's say, web scraping with authentication cookie. I remember seeing something along these lines. Yeah, do check this out. How to scrape a website that requires login. I think I'm not sure if this was the one that I came across, but yeah, so you can do this. And if you follow the instructions here, you will be able to, you need to grab all the cookies. You need to include that in your Python requests. Here that is showing you using some web request making tool, but you can do that using Python request as well. And download the information. So Cookies is the keyword. Just keep that in mind. Scrapy versus Beautiful Soup 4. Which one is more preferred? Scrapy is a more feature-rich, full-fledged kind of solution which you just give it a website and it's going to download everything for you. But Beautiful Soup is simple. Like if you're doing a simple HTML page and you just want to do a few find all queries, Beautiful Soup is good enough. Scrapy is when you want to take a page, from that page get all the other pages, from that pages get all the other pages, and basically just create a copy of the website locally. That's when you use Scrapy. Yeah, but for web scraping, I prefer Beautiful Soup. It's simpler to use. Do we have sessions every Thursday? Yes, we do have sessions every Thursday. Next Thursday, we are likely to have an AMA, I believe. Can you create a video for API calls and OAuth 2 as well? Okay, I think we can do that at some point. So we'll try and do that soon. Okay, I think we will wrap up here. Thank you so much for joining. I hope you found this helpful. This was Let's Build a Python Web Scraping Project from Scratch.